Alright, section on completing the square. Now this is going to be extra credit, but I'm going to go over it anyway. So for 38, we've got this quadratic. And normally we would just try to factor this and use the AC method, but if you know completing the square, it is a possibility. You can kind of save yourself the time of a quadratic formula. But that kind of runs into an issue when we get to number 41, for example. Now I move the 82 over here. 24 is divisible by 2, so I'm going to go completing the square as possible. I use this little formula here, and I get 144. Okay, if you remember, it's b, cut the b in half, then square it. Now this 144 is added to both sides. These guys can now form a perfect square trinomial, which means I can put it directly into this parenthetical packet. Okay, now that's why we complete the squares, to get to this stage. Now I add those two, I get 226. Now in order to get this x free from this parentheses, I'm going to have to take the square root of both sides, which I do, and I go ahead and try to take the square root of 226, but I notice that they're both prime numbers here, so it looks like I'm just going to leave it as it is, and then the 12 gets added to both sides. And so if I would have done the quadratic formula, it would have given me the same result. All right, so that's why completing the square is going to be an extra credit problem. Okay, so that's my final answer, those two decimal answers. Now the same thing here, but now, in all honesty, I probably wouldn't have even used completing the square at all because of that -3 in the front. And so what will happen, if you are forced to, you're going to have to get rid of that -3. When you get rid of that -3, it's going to go to the outside. I have to divide him by this -42 by -3 for a positive 14. This guy is he's going to stay on the other side, and that's totally fine. Okay, I'm going to move this down a little bit here. Okay, now when I move the 18 over here, I'm going to have to divide this guy using this formula here, that b divided by 2 squared. And that gives me my new synthetic c. That synthetic c is a 49, but notice that when I add the 49 to this side, I'm not only adding 49 to this side, but I'm adding 49 times -3. Now, that is such a common error that it's almost better to just use the quadratic. In fact, it is better to just use the quadratic formula. But anyways, we calculate this, we get -129, and you're thinking, whoa, if I'm going to take the square root of -129, that's going to be a problem. And you're right, it is. But that's not what you're going to do. You're going to have to divide by that -3 in order to make this happen properly. All right, so we divide by -3 because order of operations forces us to do that. Then you're going to actually figure out that this is positive 43. Then you can take your square root. All right. 43 is a prime number, so we're just going to add that 7 to both sides, which will, really what I meant is -7 to both sides, and so you get that. And that is your final answer. And again, if you were to move this 18 over, set it equal to 0, use the quadratic formula, this would have been your final answer as well. Okay, so all roads lead to Rome, so to speak. So number 40. Number 40, we got to move this 16 over here because the c value is what needs to be isolated on the right-hand side. I do the same process by dividing both sides by 4. That gives me a b of -4, and I use that special formula to get positive 4 here. Now, positive 4 here does not mean that I add positive 4 here. I actually add 4 times 4, which is 16. All right. I get 41 here, and just before I take that square root, I do have to divide both sides by 4. Okay, and then finally I take the square root. Now when I took the square root, I can't take the square root of 41 because that is prime, but I can take the square root of 4. So remember, when I take the square root of a fraction, it's no problem. I just take the square root of both of them. So the square root of 4 is 2, so that's him. And then I'm going to add 2 over to that side, and you can see that I've got, it looks something like the quadratic formula. And again, if you were to use the quadratic formula, this would have been your result. Okay. All right. In fact, if you use the quadratic formula, it would have looked like this. It would have looked like 4 plus or minus 41 divided by 2. Okay, and that would have been absolutely correct. Okay, so just keep that in mind. In fact, 41, I would have never used the completing the square in my life. You know, you can just kind of see that 15, when I move him over, when I divide by 2, I'm going to end up getting like a fraction. And like the whole point of completing the square is that you don't, you know, get a fraction. Like that's the point. And so I would have had to add that, whatever this is, I would have had to add it to the other side. Okay? And I don't, what is, that's 7.5, right? But then if 7.5 squared is some decimal. So now if I took the square root, whatever this guy was, I would have had to take the square root, have a plus or minus. And then if I want x by itself, I would have had to add this guy over there. And like this looks too much like the quadratic formula, so why not just use it? Okay? I don't even know what this is, and honestly, I would just use a calculator to figure that out anyway. All right? So, you know, use the quadratic formula, and you know, pause this video, find out what this is on a calculator, use the quadratic formula, get that decimal, figure out what that is in your calculator, and if they match, then you know you did it right. But it doesn't, you know, this is really a quadratic formula problem. And I believe that is it for completing the square. All right.